Welcome to the UH Institute for Astronomy's live stream from the Ohana Stargazing event at SALT at our Kakaʻako. We'll be observing the moon here momentarily. We're just getting set up as the sun is setting. If you have questions, you can put them in the chat and we'll try to answer them. Thanks for joining. Thanks for joining our live stream. We've got a little bit of clouds, so we've lost our view of the moon for now. So hopefully we'll be able to catch some bright objects. It's clouding up pretty well right here in Kakaʻako, so hopefully we'll be able to catch some peaks of the moon through the clouds. But for right now, we don't have anything to look at. We apologize. We do not have control over the weather. If you have any astronomy questions, you can put them into the chat and we'll answer them by text or verbally. So while we wait for the clouds to clear, I've put up a map of the moon for us to enjoy. And today we have something like a quarter moon. So it's about half of the side that we see is lit. Actually, half of the moon is lit all the time, but we only see half of the lit part tonight. And it is actually today, October 21st, is International Observe the Moonlight. And anyone can go observe. You can observe with binoculars. You can go observe with your eyes or with a telescope. And the idea is just to go and learn a little bit about the moon. So I've got a map of the moon up here. And you can see some of the dark areas that before people understood the moon, people thought might be oceans, and they have that sort of smooth, darker look of oceans. So they are called mare, which is the Latin word for ocean. And so you can see quite a lot of those big circular features. And then you can see a number of craters caused by impacts of asteroids on the moon. And if the Earth had no atmosphere and if the Earth had no moon, this is what the Earth would look like. We'd be covered in craters, although we would have an atmosphere. If we had our atmosphere also protects us. So without an atmosphere, you'd get all these craters as well. The atmosphere burns up the smaller rocks that hit us, so we wouldn't have the smaller craters. So like I said, if you have any questions, go ahead and put them into the chat in the stream. And we will try to answer them as best as we can. It was beautiful and clear about an hour ago, and the clouds seem to be blowing in. So we're going to just take a pause here while the event here has an opening Oli, and we'll come back in a few minutes. All right, there you go. So we've got the moon right there for you to see live from the rooftop of the parking lot at our Kakaʻako. So you can see the various features that you saw on the map before. They're rotated because the image is not at the same orientation as the map I showed you. But with a little bit of work, you can recognize them. There is the very circular looking mare in the sort of top right. That's Mare Crisius. And then you may know very famously the Sea of Tranquility, or the Mare Tranquillitatis. I don't know. Which is sort of right in the middle vertically. You got them. So there's Mare Crisium, the very circular looking one, and to the left of it is Mare Tranquillitatis, the Sea of Tranquility, where I believe we have landed some moon missions. And to the left and up of that is Mare Serenitatis. And you can see there's a kind of dividing line between the dark and the bright part of the moon. That's called the terminator, not like Arnold Schwarzenegger, but like the divider. And then if you got a zoomed in view of the moon, you can really see the shadows of the crater edges, crater rims that make it look very three-dimensional. And so we've got the controls on there because the tracking the moon's a little tricky. I don't know if we can zoom in over here. I've got my colleague Sage Constantino, a graduate student at the Institute for Astronomy, is running the telescope for me. The telescope that we're using is called an EV-scope Equinox 2. It is a fully digital telescope, so it has a digital detector inside of it and is run off of an iPad or Android tablet or an iPhone. And you can control it from there, take pictures. And now you see the dark coming in. Here comes some clouds. And that is what all astronomers on the ground have to contend with, clouds. So whether we are on the rooftop in Kakaʻako or high on the summit of Mauna Kea or Haleakala or in Chile, when the clouds come overhead, we are out of photons, we're out of light and out of luck. And that's what we have right now. Some of the clouds are coming and going. There we go. Looks like it's going to be like this for much of the evening. It's just, the sun is just set. We've got some beautiful pink clouds on the horizon. So when it gets a little bit darker, we'll keep observing the moon for a while, and then we're going to switch over to beautiful Saturn and hopefully be able to see some of its rings. And here comes some more clouds. Oh. All right, everyone, blow hard and blow those clouds out of the way. Oh, thank you. It worked. Look at that. Keep going, keep going. So if you have questions about the geology of the moon, I can try to answer them. Although I'm by no means a lunar expert, I study faraway galaxies. The diameter of the moon is about 1/4 the diameter of the Earth. And a fun fact, our moon is not the largest in the solar system, it is the largest compared to the planet that it orbits. And some scientists think that that has helped life develop here on Earth by protecting us from having lots of large asteroid impacts, because the moon's gravity acts as a gravitational shield, knocking asteroids off course that would otherwise have impacted Earth. Of course, some asteroids still make it. Dinosaurs were wiped out by the asteroids. But the moon does prevent a lot of those impacts from happening. And we can imagine a planet in another solar system that would be just like Earth, but if it didn't have a large moon, it might not have time for intelligent life to evolve before an asteroid impact made serious damage to the biology on that planet. That moon you see up in the sky is about 250,000 miles from Earth. It's something like 238,000, but I think it's easier for people to remember nice round numbers. So 250,000 miles. The Earth's diameter is about 10,000 miles. So it's about 25 Earth diameters from us. And that's as far as humans have ever traveled in space out to the moon. And you can compare that to the distance to the sun, which is about 100 million miles. So we have not traveled far in our solar system at all. Nope, and here comes some thick clouds have taken over and the moon is gone. Bye-bye for now. We'll try to bring it back once the clouds pass. Again, if you're watching us on Zoom, welcome. We are on the rooftop in not dark at all Kakaʻako in Honolulu. But this digital telescope is quite nice. It subtracts the background light. And let me switch over while the moon is gone to a map of the moon that we were looking at before. So hopefully when the clouds clear, we'll have our view of the moon. And we were looking basically at the right half of this image earlier. The left half of the moon, as we see it here, or the east in the sky, west on the moon side, was not illuminated. So it was called a quarter moon. And this time in the lunar cycle is a good one to watch if you've got telescope or binoculars, because you get the great views along the terminator and you can see the craters and their rims, things like that. You see me looking off to the side in my little inset here. I'm looking at my trusty telescope operator and his view of the moon, and it looks like it is back. So let me switch sharing back to our telescope view. That always takes a few seconds to swap over. And we'll be doing this as the clouds come in and out. There you go. There's the moon. You can see the clouds passing in front of it. And he's trying to keep the telescope pointed at the moon. Oh, come on, clouds.
20 seconds.
All right. Looks like we've got a little bit of the moon there. Yep, there you go. We were actually out at Pearl Harbor Elementary School doing the same kind of thing yesterday with a bunch of elementary school kids and their ohana, and that was a lot of fun. We got to observe the moon. We actually got there before sunset and looked at the sun for a little bit. Then we looked at Saturn. We could see Saturn, its rings, and a couple of moons in some of our telescopes. And in this one, as we will do later tonight, we looked at the Ring Nebula, which is the leftover of a dead star, and then Andromeda Galaxy, which is a huge galaxy similar to our own. And it looks like we have lost the moon again. That is unfortunate. So we're back to our map of the moon, and we'll hang there So while we're fighting with the clouds here to observe the moon, we are keeping an eye out to see if it gets dark enough for us to see Saturn. And that should be happening if the clouds cooperate in about 10 or 15 minutes, I'm going to guess. Luckily, Saturn is sort of in the east, whereas sun sets in the west. So while the western horizon is still very bright, over towards the east, where Saturn is rising, is starting to get nice and kind of darkish blue. So hopefully we'll be able to pick that out and aim at it soon. And right now the moon is in some clouds, so we're taking a break from observing that. I'm just showing you a map of the moon so you can familiarize yourself with some of the famous landmarks on the moon. And if you are in Honolulu, come on out to Salt at our Kakaʻako. There's about a dozen telescopes on the roof, along with some food vendors and some music and live music. And downstairs in what they call the barn, there's activities from the Polynesian Voyaging Society, Ohana Kilo Hoku, the Hawaii Lego Users Group, and some others. And we have reacquired the moon, so we're going to hop back to show you that live. Oh, there's a beautiful view of the terminator of the moon. So you can really see the craters in their shadows that are being cast in them. All right, thank you, Sage, for zooming on in there. And you can even see the craters within craters on top of craters as the generations of impacts have hit the moon. And now we've zoomed back out. Sorry for the changes in brightness. We're trying to adjust the timing of the exposures to give you as much detail as possible. All right, there's an excellent view of some of the mare, which are smooth from historical lava flows and geology on the moon. And then you can see the craters, and we can age date the craters by looking at how many craters are on top of an existing crater and sort of get an idea of how old some of the craters might be. And you know what, astronauts have brought back a few kilograms of lunar material from the moon on our various Apollo missions to the moon. And that has been analyzed in labs. Quite a few years ago, there was an exhibit at the Bishop Museum where they had a tiny vial of lunar material that you could see, but it basically just looks like gray dust and rocks. All right, so right now we see that Saturn is visible. So we're going to take a couple of minute break while we go swing over to Saturn and acquire it. And so the video from the iPad from the EV scope will disappear, and I'll put up the moon map and take a break from talking for about 2 minutes.
Still working on it.
All right, well, if you're in Honolulu and you look up now, you will see something like this in the sky, although probably some clouds as well. You will see a quarter moon. And if you look off to the sort of left to the east of the quarter moon, and you can see what looks like a bright little bit yellowish star, that is Saturn. And you can see some of the constellations. There's my birth constellation, Capricornus. So there's a lot of great apps that you can use to identify what's going on in the night sky. This website, timeanddate.com, and another one, earthsky.com, they're quite good. They have sky maps. They tell you about eclipses, moon phases, and things like that. There's a lot of apps for iPhones and Android phones that you can use to identify things in the sky. Some of them are free, some of them just cost a few dollars. And most of them, you point at the sky and it will know from the orientation of the phone and where you're pointing exactly what to show you and what's visible in that direction. So those are great if you're ever wondering, oh, what's that bright object? It'll tell you. And if you're looking for satellites, there are apps that will show you what satellites are visible and when they'll pass overhead, things like the Hubble Space Telescope or the International Space Station, which can be quite bright at times as it rotates and its solar panels flash reflected sunlight at us. So we're working on getting the telescope aligned and onto Saturn. It'll take us about 5 or 10 minutes, and then we'll hopefully get a good view of Saturn if the clouds continue to cooperate. All right, we are working on getting Saturn in the telescope. It looks like we're getting close here. So hopefully here in about somewhere between 2 and 5 minutes, we'll have a view of Saturn for you to enjoy. All right, folks, let's get ready to take a look at Saturn. Here it comes in just a second. Boom, there's Saturn. You can see the rings really well, and you can see that the rings are pretty close to edge on right now. Depending on where Saturn is in its orbit and its orientation, sometimes we see the rings more or less edge on. They're pretty close to edge on. I'm looking real carefully, and I can even see the rings making a sort of line right in front of the planet as they go around in front of it, and you can see the shadow of the planet itself on the rings, which is pretty cool. And we're doing this from a rooftop with literally there's probably 200 people up here walking around, walking right next to our telescope, making it shake and vibrate. So it's not the best viewing conditions at all. But there you go. There's beautiful Saturn, the ring planet. Just a tiny bit smaller than Jupiter. Jupiter, which is the king of the planets. Jupiter and Saturn are both about 10 times as big across as the Earth, about 100,000 kilometers. So quite big. And quite far away. So Saturn is almost 10 times as far away from the sun as the Earth. We have sent quite a few spacecraft to Saturn, including Cassini, which is around there exploring.
Maria, she's a lot.
So if you're looking at Saturn through one of your telescopes at home, if you have a decent dark sky, you can see a couple of the moons around Saturn, just as you can around Jupiter. And the moons of these large planets, especially the closer in ones, the larger ones, orbit quite quickly. So the pattern of the moons that you see changes from night to night. Now, while we're looking at Saturn, I'll say that it's brother or sister planet, I guess brother, since it's named after Jupiter, a male god. Its brother planet Jupiter, has the 4 Galilean moons named after the famous astronomer Galileo Galilei, who observed those moons in a small telescope and realized that those moons were going around Jupiter and not around the sun, which is what upended our view hundreds of years ago of everything going around the sun. And in fact, he got in trouble with the church for that viewpoint at the time. But Saturn's moons also can be seen going around Saturn. And we can see the rings of Saturn, which are made up of small particles of dust and ice and rock orbiting Saturn. And if you look online from space missions or even from large telescopes, you can see really beautiful pictures of Saturn and its rings and the small gaps in its rings. And Saturn and Jupiter, because of their rather massive, they have lots of moons. Some of them are moons that formed around them, and some of them are small asteroids that have been captured. And we are discovering moons around Saturn and Jupiter all the time. So the number of moons Saturn has is up to 146. So that's pretty amazing. A few years ago, that number was about 80. So we're finding lots and lots of small asteroids that are orbiting Saturn as sort of permanent moons. You can't see those in these images, of course, and we need really big telescopes like some of those on Mauna Kea to discover these moons. So there's quite a lot of them going around Saturn. And many of them are discovered actually using the Subaru telescope on Mauna Kea, which is an 8-meter telescope. So it has a mirror that's about 33 feet across, and it has one of the largest cameras on a large telescope, so it can see a wide field of view. So you can monitor these small faint objects and watch them moving and calculate their orbits and see that they're actually orbiting Saturn. All right, so right now the telescope that we're using, this EB scope, has a sort of automatic mode where it keeps taking short exposure, short time pictures of Saturn and adding them together to make the best image possible. And what we're going to do is try to manually adjust the exposure time. And you can see that happening on screen now. And as we do that, we'll blow out Saturn. It'll look too bright, but then hopefully some of the faint moons will show up in the outer reaches of the image. So now you see Saturn is overexposed. You can't see the rings. And we're going to see if we can see some of the moons. Sky's gotten pretty dark, so if we're lucky, we'll be able to catch some. Oh, there we go. Excellent. I count 1, 2, well, you can see one moon just to the bottom left of Saturn, another upright, and then 2 farther down and to the left. So we've got 4 moons of Saturn that are visible, and we're going to try to figure out which ones they are. There's no way to know just by looking at it, since they orbit so quickly. Some of these moons take only 1 week or even less to go around Saturn. So from night to night, their positions change relative to each other. Oh, it's interesting. We don't see Tethys and Dione. All right, so, or maybe this is Tethys and Dione down here. And then this is Enceladus.
That should be Enceladus. I think Rhea, so it's
Yeah. Oh boy, that's a loud airplane passing overhead. Okay, so we believe that up and to the right of Saturn is the moon Enceladus. And then the very faint object just to the left of Saturn might be a background star. And then further away, we have Tethys and Dione. So the bottom left moon is Dione. Just above and to the right of that is Tethys. And then on the opposite side of Saturn is Enceladus. So you don't see the moons of Saturn. You don't see the rings of Saturn right now because we've overexposed Saturn so that you can see the moons. And if we had a little bit bigger field of view, then way up and off to the right would be Rhea. So those are the 4 brightest, biggest moons of Saturn. Awesome. So now that we've taken a quick look at Saturn's moons, we're going to go. So we're going to return to viewing Saturn with its moons. I mean, Saturn's rings. So a telescope is just going to take a moment to recenter Saturn and then take proper length exposure so that we can see the moon. And maybe you can hear in the background, we've got some great live music up here on the roof of the parking lot at Salt at our Kakaʻako. So everything that you're seeing on screen, the telescope is doing kind of automatically. We're controlling it from an iPad right next to me. And then once it's happy with its pointing, it will try to adjust the exposure time so that we can see the rings of Saturn. And we'll hang out looking at Saturn for a few minutes because everybody loves Saturn. And after that, we're going to go and start looking at some deep sky objects, objects that you can't see with your naked eye looking through telescopes, except some really big ones in a really dark spot. All right, there's Saturn. So we're going to let it automatically set the exposure, and then it's going to start adding up images again, and then hopefully we'll get a better picture. There we go. So that'll clear up over time as the telescope takes more pictures and corrects for all of the blurring and vibration that's going on. But there's Saturn and its rings, and you can see the shadow of Saturn on its rings as well. So we'll stay here on Saturn for another 5 or 10 minutes, and I'll pause the narration for a bit, and then I'll be back soon. And when I'm back, we will switch over to trying for a deep sky object, the Ring Nebula. All right, folks. We think that's been enough of Saturn, so we are going to head on over to the Ring Nebula. And what we're going to do is tell the telescope to go over there. It knows where it's pointing, and you will see it slewing, moving around. You might see some bright object pass through the image. And then it will start taking pictures of the area around the Ring Nebula. There you go. Something bright just passed through the field of view. And once it gets there, it's going to start taking pictures and adding them together. And as they add together and it takes out the bright background, you'll start to see lots of stars and then eventually a bright rainbow colored ring, which gives this nebula its name. And a nebula is just a word for something fuzzy, also one of Marvel's superheroes. And so before scientists knew what all these fuzzy things were, they were all called nebulae. And as it turns out, there are all kinds of different objects that can be fuzzy and that we call nebulae. Even things that we now know as galaxies, like the Andromeda Galaxy, were called nebulae before we knew those were faraway galaxies full of millions and billions of stars. But the Ring Nebula is the leftover remains of a dead star that shed its layers, and the heat from the inner dead star is ionizing the different kinds of atoms, which produce different colors: oxygen, nitrogen, and other things that are visible in the nebula. So the telescope's moving it, making its way over there, and as it takes short exposures and adds them up to make a deeper exposure, by deeper we mean like a longer time exposure, then we'll start to see more features. So if you're looking for the Ring Nebula on our screen, you're not going to see it yet. Unfortunately, our parking lot is not the best place to put a telescope, and the whole structure is vibrating, so it's giving the telescope a hard time adding together the exposures. But we're going to keep trying and see if we can get the Ring Nebula here for you in a few minutes. while we wait for our telescope to try to capture the Ring Nebula, this is a picture from, I think, space of the Ring Nebula itself. So the Ring Nebula is what is called a planetary nebula. Now, it has nothing to do with planets. It's a horrible name meant to confuse people. But actually, the name comes from the fact that in small telescopes a long time ago, these nebulae looked like colorful planets. And so they were called planetary because they resembled planets. But once we could see more detail, we could see that that's not what they were. So this is what will happen to our sun at the end of its life. It's going to shed its outer layers and then leave a hot, hot core that will illuminate those shed layers and cause them to glow, ionize those materials and cause them to glow. And the different atoms that are visible there, green is oxygen, the red is probably hydrogen, there's carbon there. Those are all products of the fusion reactions in the center of a star, and those are spewed out into space, and then those will help form new stars in the future. So what you're seeing now, if you're joining our live stream, is a recent picture from James Webb Space Telescope of the Ring Nebula, which we're trying to get an image of here, but it looks like between the lights in the parking lot, the bright lights of Honolulu, and the vibrations of all the people and cars inside the parking structure, the telescope is not having a good time trying to add up the images to get a deep exposure. So if we can't get that to work, we're gonna take a shot at either going back to Saturn or trying the Andromeda galaxy and see if we can get that to work. If you have any questions and you're watching the live stream, you can go ahead and put them in the chat. and we will answer them. They don't have to be about the Ring Nebula. They can be about telescopes, about other objects in the sky, about being a scientist or an astronomer. We're happy to answer them for you. So it looks like the conditions are not favorable for deep sky objects up here tonight. So my colleague Sage and I are discussing what we might try to observe next that we might be able to get besides of the moon and Saturn, which we had earlier. Now, I study faraway galaxies, but Sage studies something much closer. He studies our own sun.
Yep,
And
solar
he-
astronomer. There's one star I care about, and it's long gone.
But Sage and his advisor, Shadia Habal, they go on eclipse expeditions to view solar eclipses when you can study the outer layers of the sun, the corona of the sun, and get some beautiful images. So that's pretty spectacular work too. So since Sage is here helping run our telescope, I thought I'd show you a little bit about the kind of work that he's doing. And his advisor and her team are called the Solar Wind Sherpas.
That's right.
And so this spectacular image that you can see on the screen now is one of the images that they've taken during a total solar eclipse. So our friend the moon, which we may go back and observe later, is blocking out the sun, and you can see the outer red and green are the outer layers of the sun observed in ionized iron, I believe.
Yep, that's
Two
right.
different levels of ionization of iron, which happen at different temperatures. So by looking at which levels of ionization the iron has, you can map out the temperature structure in this very tenuous hot gas in the corona of the sun. All right, so if you're joining our live stream now, I've just got an image of a solar eclipse up here. There will be a solar eclipse on the mainland in April. And my colleague who is operating our digital telescope, Sage Constantino, works as part of the research team that observes these solar eclipses. And we were trying to do some deep sky objects here, but the rooftop deck here in the parking lot is vibrating like crazy. So we have given up on that idea. So I think we're gonna maybe go back to Saturn. And so we should have Saturn here in a few minutes. So I'm going to switch back to the view of our EV scope controller as we slew our way back to Saturn. That'll take us probably about 2 minutes to get there and centered up. And I gotta say, we've got some food vendors here. And it smells pretty darn good and I'm getting hungry. So we may have to go grab some food at some time and take a break from our live stream here. All right, I see Saturn coming into the field of view here. There it is, teeny tiny, and in a moment, we'll zoom in on that. And I can already see we've got a good view of the rings. There we go, it's centering up. I can already see the shadow of the planet on the rings right there. That's beautiful. So we'll get a nice zoomed in image of Saturn here. That motion is just the telescope getting Saturn centered right in the middle of the field of view for us. And if you look really carefully, you'll see the rings going across the disk of Saturn. I don't know if it's easy to see. But I can see a thin, dark line, kind of gray line going across the center of the disk there. That is the rings blocking some of the light reflected from the surface of Saturn. Now, keep in mind, none of these planets' invisible light glow by themselves. It's all reflected sunlight. But when we look at these planets at other colors of light, like the infrared, we can actually see them glowing from their own light, kind of like the infrared light our bodies give off, which is how those night vision cameras can see us. And if you're just joining us, that's Saturn right there in the view. And Saturn is about 10 times as big across as Earth. So it's about 100,000 kilometers across. and about 100 million miles from the sun. Long way out. And in a little bit after looking at Saturn, we'll change the exposure time in the zoom, and we will take a look at being able to see some of Saturn's moons. So while we're looking at Saturn here, I'm gonna take a quick break and show you how you can know which moons of Saturn you might be seeing through a small telescope. And we're gonna switch to that view in a few minutes. But meantime, let me show you that if you go to Sky and Telescope's website, they have a little screen that shows you Saturn, and then the moons are labeled. Let me zoom in there for you. Now, the view we have in our telescope is going to be rotated or flipped relative to this, and the scale might be a little bit different. But you will see Saturn and its rings, and you are going to see in our view that there is one moon close to the planet, then two further away on the opposite side, and then we do not have a big enough field of view to see Rhea and Titan. So we are going to switch back to our telescope view and just imagine this rotated here. And here we go. We should have our iPad view, and there you go. There is Enceladus close to Saturn and the two moons on the opposite side that we were showing you before. Now it's totally rotated compared to the image we had before. That, of course, we could just spin our image around to match it. So we have Tethys and Dione over here on the bottom left, and Enceladus over to the top right. And I think the very faint dot next to Saturn might be a background star, but I'm not sure.
Mimus?
Oh, it could be the moon Mimas. Yep, if that's on the same side as, oh no, Mimas is on the, yep. So quite possibly that's Mimas. Yep, I'm thinking so. So we're seeing 1, 2, and then when we're zoomed out, 3, 4 moons of Saturn. Very good. So Enceladus to the top right, Mimas, M-I-M-A-S. Bottom left, a little bit of Saturn, and then the two in the bottom left corner are Tethys and Dione. And if we had a bigger field of view, I think it's just outside our field of view in the top right, we would have Rhea, and way down in the bottom left, we would have Titan. So if we had a wider field of view, we could tonight see 1, 2, 3, 4, 6 moons of Saturn out of the over 150 moons that Saturn has. Now, most of Saturn's moons are teeny tiny. So we're going to see if we can capture Rhea over here in just a minute. I think that's what my colleague Sage is trying to do for us. Okay, I see. There's the 4 moons we were looking at before. And we haven't seen Rhea yet. We're trying to move Saturn to the bottom corner of the screen and see if we can get Rhea in there. Rhea should be about as far on the other side, maybe 1.5 times as far as Dione. So I'm thinking we should be able to see it. Yeah, I'm thinking, let's go back to the full screen view and see if we can find No? Be about there, I'm thinking.
All right, best I can do there.
Yeah, I guess we didn't have any luck finding Rhea, but I promise you it's there. So we'll put Saturn back in the middle. And then we'll see the four moons we were looking at before. Now Enceladus is very close to Saturn. It's about 150,000 miles from Saturn, which is closer than Earth's moon is to us. Earth's moon is only 250,000 miles from Earth. So Enceladus is 100,000 miles closer to Saturn, and Saturn is much more massive. So Enceladus only takes 33 hours to go around Saturn. So if we were to look tomorrow, Enceladus, or even a few hours, we'd see Enceladus in a different part of its orbit around Saturn. And when things get that close to what they're orbiting, this is true for Mercury as well around the sun, and it is true for our moon around the Earth. It gets what's called tidally locked. So our moon is always facing the same side towards Earth. And similarly, Enceladus is always facing its same side towards Saturn. One of the other moons that we saw is Tethys. Tethys is actually quite small. It's only 331 miles in radius or 600 miles in diameter. So that's very small. It has a super gigantic crater on one side that's quite obvious. And yet we can see that 600-mile cross object easily in our telescope from here, which I think is pretty cool. And that's 100 million miles away from us. We've known these bright moons of Saturn for about since the late 1600s. The astronomer Cassini found many of Saturn's moons, and we had a spacecraft called Cassini that went and explored Saturn and its environment and its moons, sent back amazing pictures of Saturn. So those fantastic pictures you all see of planets often come from spacecraft that are observing them up close. Okay, so here we have Enceladus to the top right, Mimas just to the bottom left of Saturn. Saturn is that blown out bright object in the middle. And then Tethys down and to the left, and that's what I was just talking about. And then Dione, the last one we see in this image. So as you can see, for instance, Mimas, or Mimas, I'm not sure how you pronounce it, is very small. You can guess that because it's close to Saturn, yet it's quite faint. And Mimas is only 250 miles across. So Mimas is about the size of the Big Island, a little bit bigger than that. So imagine a rock, this round rock the size of the Big Island, round marble the size of the Big Island orbiting Saturn. And that's that faint dot we see off to the left right now. And I'm going to show you a picture of Mimas because Mimas is pretty interesting. So here is coming up a picture of Mimas. Mimas looks like the Death Star. It's got a big impact crater. And when an impact crater happens, you can actually see it doesn't just make the round ring of the crater, But during impact, the material that is shot up by the impactor goes up and falls back down and makes this sort of mountain in the middle of the crater. And when you have geology on a planet or a moon, it can erase that over time. But you can see this elevated section in the middle from the impact. So this moon that we're looking at, Mimas, one of Saturn's moons, you can see is completely pockmarked by craters. And this is just an image I pulled off Wikipedia, but you can see the craters on top of craters on top of craters that have happened from the many impacts on this moon. And again, this is not much bigger than the Big Island orbiting Saturn. And yet this is still one of Saturn's bigger moons. Saturn's small moons are only a few miles across, so those are impossible for us to see, and we need really big telescopes to discover them. So I'm going to send us back to our image here. So we were just looking at pictures of this little white dot just down and to the left of Saturn, the moon, Mimas. And like I said, if you come back tomorrow, you'll get the moon's orbits are quite short, so they'll be in different positions.
You do okay if I meant that so quickly. Or yeah, she's.
So Tethys takes about 45 hours to go around Saturn. Oh,
My turn now being to stand on.
oh, do we have some clouds? Maybe we have some cloud. Oh, there we go. All right, we're getting some clouds, so I've boosted the exposure time a bit, but we may lose Saturn here shortly. But it's pretty amazing. That little dot there, Mimas, takes 33 hours to go around Saturn, and Enceladus over here takes 45 hours. So in just 2 of our days, it'll have made a full orbit around the giant planet Saturn. So again, if you're watching our live stream, go ahead and put some questions in the chat, and we'll be happy to answer them. And right now, tonight, if you're just joining us, we're at SALT at our Kakaʻako on the rooftop of the parking deck as a part of Ohana Stargazing event. Well, we do outreach activities all the time with the community. Earlier today, we were out at UH Manoa, which is our home base, doing an event called Discover UH Manoa, where many of the departments had all kinds of activities for people to come and explore what the university does, the research that we do, the teaching that we do, the programs that we offer. Last night, we were out at Pearl Harbor Elementary School as a part of an Avid Science Night. We'll be out stargazing at the Campbell Kapolei School Complex in 2 weeks. And of course, we don't just do outreach. We have an undergraduate program, a graduate program where people get their doctorate in astronomy, a very intensive research program using observatories in Mauna Kea, Haleakala, elsewhere around the world, and in space. And astronomers at the Institute for Astronomy study everything from the sun to comets to planets around other stars, galaxies, and the larger scale things in the universe. For anybody watching the live stream, I'm going to leave this image of Saturn's moons up and go take a dinner break, and I'll be back in about 5 minutes. All right, we're gonna get Saturn centered back up in here and get back to the view with the rings. Unfortunately, with the bright lights and vibrations here, there's not much more we can observe. All right, folks, we think we see Jupiter poking through the clouds, so we are going to go see if we can go get it for you. So come on back in a couple of minutes and we will see if we have it. And if not, maybe we'll go swing back to the moon one final time if we can still see it amongst the lights in the buildings. So right now we're in the middle of slewing all the way over to Jupiter. So it's going to take a couple of minutes for the telescope to acquire it and get some images. And there are clouds in that area, so we may or may not have luck capturing it. Right now, it looks like a hole in the clouds right where Jupiter is, so hopefully we'll be able to see it. Well, you can see Jupiter just coming in and clouds are just covering it up. We're looking with our naked eyes here, and we see that the clouds are covering it up. Oh, bad timing. Bye Jupiter into the clouds. Unfortunately, the lower eastern horizon is pretty cloudy from here. Sorry about that, folks. We'll go and try to find you something else in a few minutes. All right, since we lost Saturn in the clouds, the moon is pretty close to overhead right now. So we're going to slew over there and go back to taking a look at the moon since it is International Observe the Moon Night. So whether you're on our live stream or not, go ahead and hop outside and take a look at the moon. All right, that mess you see on the screen is because there are clouds heading near the moon too, so we're gonna try to capture it for you here. But it might take a little bit of time. Hoping the weather will cooperate with us. All right, we are trying to chase holes in the clouds. So we did not succeed in getting Jupiter. We saw it here for another minute and it's going behind another cloud. We did not succeed in the moon, and that's certainly bright enough to see. So we are going for Saturn, which is currently in a clear patch. Oh man, Saturn's clouded in too right now, so we're gonna just hang out here and take a break. So since we're clouded out, I put back a beautiful image of a sun during solar eclipse taken by the Solar Wind Sherpas, a research team headquartered at the UH Institute for Astronomy that goes around the world observing the sun during eclipses and looking at the structure of the solar corona, the outer layers of the sun, and trying to understand how the outer layers of the sun and the magnetic field of the sun interact and produce space weather, solar weather, which can impact us here on Earth. And the next total solar eclipse is going to be in April on the mainland US and down into Mexico. And if you have a chance to go observe it, I 1000% encourage you to do so. I personally went and saw my first one in 2017 as already a pretty seasoned astronomer. And I got to say, it was pretty mind blowing, even naked eye, just seeing the eclipse. As soon as it hit totality, taking off those solar shades, you could totally see the streamers in the sun. The sky get dark, you could see stars, you could see Venus. Birds were acting all weird. It was quite an amazing event. If you have an opportunity to go, and it's already getting probably impossible to find housing along the path of totality. I booked a hotel room 4 or 6 months ago, so but you should try. Grab an RV, sit in a car, check it out. We will not have one in Hawaii for a long time.
I know that's not.
We won't even have one in this century in Honolulu, in Hawaii. No total solar eclipses for the next 77 years at least. So gotta go travel if you want to catch one. And if you heard of that Ring of Fire eclipse a few days ago, that was only a very tiny bit partial eclipse right here in Honolulu, a few percent. And then places like California saw like 60–70% yet to be in path totality. I've yet to see one of those Ring of Fire eclipses.
And so he. Directions of how.
All right, folks, we're making an executive decision here. We are having trouble with the clouds, and it looks like that's going to only get worse till the end of this event. So we are going to take a break. Actually, we're going to end our live stream now. So if you've been joining us so far, thank you so much for being patient with us in the weather. And keep an eye out on our social media, UHIFA, on Instagram, Facebook, YouTube, occasionally Twitter, aka X. And yeah, keep an eye on it for our upcoming public events, stargazing, public talks, and things like that. Thank you for joining us, and we hope you all have a good night.
Your 4 quadrants, 360 degrees, so you've got 90 at least.